In this example, we want to find the probability of a z-score, and we have a clinical trial in which we measure the concentration of a specific biomarker, whatever this biomarker is, in a group of 8 patients. We've got our data here. The biomarker concentration in milligram per cubic decimeters, and I've written them out here again. And what we know is that this particular biomarker has a normal distribution in the healthy population. So what this actually means is that if we look at the distribution of this biomarker in the population, we would find a normal distribution like this. And here it is centered around the mean, which is 8.37 milligram per decimeter cubed. So here we have our concentration of the biomarker. And we know that it has a standard deviation, and I indicate it like that. So this would be our standard deviation of 2.2 milligram per cubic decimeter. And we know that in a normal distribution, we've got 68% of the data here within one standard deviation. Now, of course, when we take a sample, then we would use a different distribution. So this here was the normal distribution with 8.37 and the standard deviation of 2.2. Let's write it like that. When we take a sample, we are dealing with a sampling distribution, and we would get, again, a normal distribution, which is pretty much like the distribution that we had before. That's not a very good normal distribution. Let's do it like that. Again, it is centered around 8.37, but our standard deviation for this normal distribution would be much smaller, because now this standard deviation is the standard deviation of the means, and this would be our original standard deviation divided by the square root of the observation. And this is also referred to as the standard error of the mean. So this would be much smaller than in the case of the original normal distribution. So again, we've got a normal distribution with mu, but this time the distribution is with this standard error of the mean. And since it is quite cumbersome to calculate any p-values from something like that, we can convert this sampling distribution into a standardized normal distribution, where we use the mean of 0 and the standard deviation of 1. By what we do is just simply, instead of the mean, we use a z-score. So this would then look like that. Again, we would have, and hopefully this time my normal distribution looks a little bit better. That's okay. So instead of the mean, we would plot a z-score here. Again, we have a mean, but now it is centered around 0, and here we've got our standard deviations, and these are sort of transformed standard error of the mean, and I indicate that here with a transformed index. So how do we calculate the z-score? So the z-score we can just simply calculate by taking the difference between an observed mean minus the population mean, and we divide that by the standard error of the mean that we have got here, so which would be the population standard deviation divided by the square root of n. Okay, let's get going. So first of all, we've got our data here, and we can figure out the number of counts that we have of observations with this equation here. We would get 8 observations, so that's good. We can calculate the mean with this equation here. So our mean of our observations would be 10.78 milligram per cubic decimeter, and that is the mean of these data here of our observations. We can also calculate the standard error of the mean, and as I said, this standard error of the mean, this here is this population standard deviation divided by square root of 8, and that was 2.2. Okay, so we've got the same. We now can calculate the difference between the two means. So that is mean minus the population mean, 2.405, and we calculate the corresponding z-score, which is this difference here divided by the standard error of the mean. So that is our z-score. If we look at our standard curve here, what we are looking for is a z-score that is around 3. So here would be our z-score. So we are basically looking at a z-score or larger than 3. So we are looking at the area under the curve that is to the right of this z-score. And as we can see, this is probably a very small number. So what we can use for that is the norm S distribution function in Excel. That's this function here, which doesn't give us the z-score to the right. It actually gives us the z-score, or the p-value, I should say, the p-value to the left of this z-score. And if we put that in with this formula here, we are putting in the z-score, and we say true. This true means give us everything that is to the left of the z-score. We get a probability of 0.999. So the probability of this part here is 0.999, and we can now just simply say we know that the area under the normal distribution curve is 1, and in order to find the right side of the z-score, we just simply calculate 1 minus this dashed score, which gives us 0.009, which is roughly 0.001. So the probability of finding a z-score of 3 is 0.001. Or in other words, the probability of finding this mean of 10.78 milligram per cubic decimeters. The probability of finding this mean for a normal distribution with 8.37 and 2.2 standard deviation is roughly 0.001, or roughly 0.1%. It's fairly small, but not totally impossible or unlikely, but it is not very high probability of finding this z-score of 3.09. So I hope this makes sense, and thank you very much for watching.